So back in the day when we talked about inverse functions, the first thing we asked is, does this function even have an inverse function? And remember how we said in order for something to have an inverse function, it had to pass the horizontal line test. Do you guys remember that? Yeah. Because that's when, right, the inverse will become a function. Now, so then when we get to sine or cosine functions, okay, these oscillate forever and ever and ever, so for sure they will not pass the horizontal line test, right? Well, like if we look at this one right over here, this does not pass the horizontal line test. So what does that mean? No sinusoidal function can ever have an inverse. Well, that doesn't work either. So we have a way around it. The way around it is, well, wait, why don't we restrict the domain and we only take a small portion of the sine function so that it does pass the horizontal line test, right? So if I only take this part of it, that passes the horizontal line test, and here and here. Well, which small part are we going to take? Well, obviously it makes sense to do it, as close to the origin as possible. So what we do is, okay, we say from here to here, right? If I only take that blue part and restrict my domain from here to here, that does pass the horizontal line test, and I can find the inverse of that portion of the graph. The downside is you're only restricted to that part of the coordinate plane. So I had copied these notes from my pre-calc, and so the notation is a little bit different, I realized. So if this is pi, then this is pi over 2, and then here, this is negative pi over 2. So what we're going to do is we're just going to take the version from negative pi over 2 to pi over 2. That means my restricted function is going to have a domain from negative pi over 2 to theta to pi over 2. Okay, that's going to be the domain. The notation here inside the bracket, these mean the same thing. That's more like notation that we use in pre-calculus. Okay, so when that happens, right, that's the domain. So these are the theta values or the x values. And then the y values are just from negative 1 to 1. Is that right? Okay, so now, so here we're going to have f of x and f inverse of x. So what's going to happen is the domain of f of x is going to go from negative pi over 2 to pi over 2. And the range of f of x is going to go from negative 1 to 1, right? Okay. What was the first thing we did when we were given a function and you had to find the inverse of it? What was the first thing you did? You swapped x and y, right? When you swap x and y, remember you also swap domain and range, right? So now, if you have the inverse function of this, then these things get swapped. So the domain for the inverse becomes negative 1 to 1, and the range becomes negative pi over 2 to pi over 2. Don't mind the variables for now, okay? Just know that the domain and range will just switch. Okay, so basically what the inverse function will do is, given a value, 1, root 3 over 2, negative a half, negative 2 over 2, it helps you find the angle. Pi over 3, negative pi over 4, 2 pi over 3, and so on. Okay, so for the inverse sine function, the way it's written is like this: sine to the negative 1 of x, or arc sine of x. These two are synonyms. Okay? the way we read it is y equals the inverse sine of x. And so take a look at what happens when you graph the inverse now. Take a look at where the negative pi over 2 and the pi over 2 end up. They end up on the y-axis. And on the x-axis, you have negative 1 to 1. Do you see that? Do you see how it's switched? So compare this to this. This is the original function. The y value goes from negative 1 to 1, and these go from negative pi over 2 to pi over 2, and here it gets flipped over. X's and y's switch, because that's what inverses do. Okay. So here's one way we can use the inverse functions. We all know that the sine of 60 is root 3 over 2, right? We learned this right before we started graphing. So now, if I were to ask you this question, inverse sine of root 3 over 2, what this is saying is, what is the angle for which the sine is root 3 over 2? And what is that angle? 60 degrees, okay? So if I was walking down the street and there was a billboard, just a blank white, or just a white billboard, and on the billboard it said this, just that, I'd be like, oh, someone's looking for an angle for which the sine is root 3 over 2. That's 60 degrees, okay? So that's what inverse sine is, okay? So let's summarize inverse sine. When you have something in this form, y always represents the angle, okay? So this answer always represents the angle. X, which is this, must always be between negative 1 and 1. So for example, if I have inverse sine of 4, doesn't work, okay? Now, if x is positive, the angle is in this quadrant. If x is negative, the angle is in this quadrant. Okay, so let's think about this for a minute. You know how we're only going from negative pi over 2 to pi over 2? Let's go on the unit circle for a minute. Where is negative pi over 2? Up, down, right, left, down, right here, negative pi over 2. So, okay, so when we look at the unit circle, convention is you always start at 0 and then you're like pi over 2, pi, 3 pi over 2, blah, 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 blah. But there is no law that says that's where you have to start. If you started a little bit before that, it would be negative pi over 2, right? And then when you go over here, then it's 0, and then it's pi over 2. Does that make sense to you guys? So 0, and then pi over 2. So when we say this is between negative pi over 2 to pi over 2, it's only going to go from here to here. That's it. So none of the other parts in the unit circle will exist for this. Okay, so if the angle is positive, it'll be here. If it's negative, it'll be here. Another way of looking at it is we're only going to take half of the unit circle from negative pi over 2 to pi over 2. Okay? What are these angles here? This is 0. How much is this? Pi over 6. How much is this? Pi over 4 and these are negative pi over 6, negative pi over 3, 4, and negative pi over 3. How many angles is that total? More than 6. Total? 9. Starting with here, all the way, 9. Okay, these are the only 9 angles, the special angles, that exist in the world of inverse sine. So when you're dealing with inverse sine, your answer can only be one of these 9 angles. Is 2 pi over 3 one of these 9? No, so it can't work. Is 3 pi over 4 one of these 9? Can't work. Yeah.
What if you get inverse sine of pi?
So you won't because the stuff here, that's the domain, and now the domain is from negative 1 to 1 only, no longer the angles. You see that? So if you get inverse sine of pi, that's like inverse sine of 3.14. It's not from negative 1 to 1, so it doesn't work. Okay, so here if I get inverse sine of root 2 over 2, what angle is that? 45 degrees. Okay, for what angle is sine root 2 over 2? Sine of what is root 2 over 2?
Oh.
Right? Okay, or pi over 4, it will, like, I'll specify whether I want it in degrees or radian. Okay, for this one, I want you all to raise your hand. So I want inverse sine of negative root 3 over 2. So I want the angle for which the sine is root 3 over 2, but negative. So not in the first quadrant, but in this quadrant here. Negative 60 degrees. No, because 330 is not here, right? Yeah. So I'll show you. So this will be negative pi over 3. So look, if you go back here, this is negative pi. So negative 60 is somewhere here, right? Negative 330 is somewhere here. Like, do you see how it's outside of the domain? Right. Okay. Yep.
So like if it does not fit between if x does not exist, so we're just going to the answer. Like the answer x does not exist.
Right. But for this one, it does exist. So what's the angle for which the sine is negative 1? So think about that. Raise your hand if you know. The sine has to be negative 1. Yeah. 270, but it is down here, so it's got to be negative pi over 2. Yeah?
Wait, since when is there an arc sum? What?
I even highlighted it for you. Here. So arc sine and inverse sine are the same. They're synonyms. And you can have arc cosine, arc tangent, and everything. Okay. Let's talk about cosine. Did you have a question?
No, I figured it out.
Let's talk about cosine. Cosine, when we restrict it, we can't go from negative pi over 2 to pi over 2 because that still doesn't pass the horizontal line test. So we need another another portion. This is the portion that works. So we're only going to go from 0 to pi. Now, if I look on the unit circle, where is 0? Here. Pi is here, exactly. So we know that cosine is positive here and negative there, okay? So what are the angles here? Pi over 6. Sorry, one sec. Okay, so 0, pi over 6, pi over 4, pi over 3, pi over 2. And then what's the next angle over? 2 pi over 3. Next one?
3 pi over 4. And then 5 pi over 6.
And pi. How many total angles? 9. The rest of this doesn't matter. Those are the only angles that exist in this world. Cosine is positive here and negative here. So let's summarize this. If you have something like this, y always represents the angle. So the answer is always the angle. X must always be between negative 1 and 1. And then if x is positive, it's got to be in this quadrant. If x is negative, it's got to be in this second quadrant. That's it. Okay? So look. We want arc cosine, which is inverse cosine of negative root 3 over 2. So think to yourself, what angle gives you cosine root 3 over 2? Is that the pi over 6s or the pi over 3s? Pi over 6s. But if it's negative, in this quadrant, what would it be? 5 pi over 6.
Could you write 150 or no?
You can.
Okay.
Or 150. Now, cosine is also negative root 3 over 2 at 7 pi over 6. But that's not part of my domain, so I can't use that. You see that? There's only one answer possible. If it's positive, from here. If it's negative, from here. Okay, yeah.
If it was positive, then it would be pi over 6.
Pi over 6, correct. Okay, so the next one, inverse cosine of 1. So for what angle is the cosine equal to 1? Cosine is the x value.
Oh, it's 40.
Cosine. 0. Okay, Inverse cosine of -2. So what should this value always be? Between -1 and 1. So does that work? No. So this is not possible. Okay? Because this is not between -1 and 1. Yeah.
I'm kind of confused on how you did inverse cosine of 1.
Huh? Okay, so what angle gives you cosine of 1? Cosine is the x value, right? So when you're here, you have an x value of 1. Remember, like the coordinate there is 1 comma 0, so cosine and sine.
Yeah.
So that's why it's 0 degrees
Oh,
or 0 radian.
okay. Wait.
Yeah.
If it was just normal cosine, would it be 1?
So you wouldn't have cosine of 1. You wouldn't have cosine of 1. You would have cosine of, let's say, 0 degrees, and then it would be 1.
Oh.
Okay?
Cosine
So
of
do you see how x's and y's switch? Okay. Now, tangent is a whole other situation. We didn't graph tangent, but this is what it looks like. Tangent graphs basically are like arms like this, and they just, continue forever and ever like this, over and over and over again. So again, to restrict it, well, this one's easy. You just take one arm of it, again from -pi/2 to pi/2, except tangent is undefined here and here. Okay? So when we graph this, when we put this on the unit circle, right, it's going to go from -pi/2 to pi/2 again. So here we have pi/6, pi/4, pi/3, 0, -pi/6, -pi/3, 4, -pi/3, but it's undefined here and here, so those don't work. So how many angles now? 7. So the answer to inverse tangent, it's always going to be one of these 7. So if you just put one of these at random, you have 1 in 7th chance of getting it right. Yep. Not bad at all. Okay, so again, so here is the difference now. X for tangent can take on any value. There is no limit as to what this can be. Remember how we said for sine and cosine, it has to be between -1 and 1? Not the same for tangent. Okay, so if it's positive, it's got to be in this quadrant. If it's negative, it's got to be in that quadrant. So let's see. Inverse tangent of 1. So let's think about this for a minute. For what angle is tangent 1? Tangent is opposite over adjacent. For which angle is it 1? 45 degrees or pi/4? Remember, tangent is y/x?
Yeah.
Or, right, so only for the 45 degrees, because it's 1/√2 and 1/√2, so tangent would be 1. Huh?
Oh, so they would just cancel out.
Right. Okay, so for what angle is tangent √3/3? So this, maybe we need to think about it. So it's positive, it's got to be in the first quadrant, right? So let's see. If I take the 60 degree, this is √3/2 and 1/2. So if I do opposite over adjacent, do I get √3/3 or do I just get √3? You just get √3. So which one is it going to be? The 30 degrees. Okay? Yeah.
The other has to
I kind of just
Right.
made a graph and made the y 3 and the x 3, and then it kind of looked like the 33.
Yeah, exactly. Exactly. You could do it that way as well. However way you want to visualize. I was just trying to do some trial and error, but yes, that works as well. Okay, are you sure? Is it a minute? I want you to wait. Okay, no. Okay. Yep. Oh, 3, sorry. Okay, and these are negative, right? Because it's in the bottom quadrant. Okay, now, okay, last 4 problems of the chapter. Okay. Huh? Last, oh my God, last 4 problems of this year. Oh, wow. Huh? Huh?
You're into the last 4, the hard.
Except for the 150 that's on the, huh?
Yeah,
Wait,
so we got 150
what do you mean
more,
150? I thought it was 50. Okay, that's fine. No, 150 on
On the practice test.
Oh.
So, for which one are you gonna get? Because
150, so I understand that it's 60, but why
We only have
is
50
it
miles.
negative 60?
because this is negative, it's in the negative quadrant. Okay, so look, hey guys, what, okay, is tangent positive or negative in this quadrant? Positive. Is tangent positive or negative in this quadrant?
Negative.
Negative. That's why when you have a negative one, you gotta go to that bottom quadrant. Okay? So it all fits in. When you have a negative one, you have to go to the bottom quadrant because tangent is positive up there, negative up here. Okay, now, here we have some, composite functions. With these, we always start from the inside. Okay? I actually don't need you to do this to a decimal because it's gonna be on the no calculator section. Okay, let's do this. So you start from the inside, cover the tangent, we don't care about that. Inverse cosine of 4/7. What this is telling you is there is some mystery angle theta, the cosine of which is 4/7. All right? Cosine, remember, is adjacent over hypotenuse. So when I draw this is my theta. 4 and 7 is the adjacent and the hypotenuse. Now all I need to do is find this side. It'll be root 33. You all know how to find that one. Good old Pythagoras, okay? Now, what did I say about this before? I said there is some mystery angle theta, the cosine of which is that. Now that you've done your cute little triangle, you now zoom out and you need to find the tangent of this setup that you drew. What is the tangent of this theta? Root 33/7, 4. That's it. That's a lot easier than it seemed. Huh?
I thought we had to do more of this.
That's it.
Yeah,
Nope.
This is easier than others. I like this.
Yep. So let's do this one. This is the theta. You start from the inside. There is a mystery angle, the tangent of which is 3/8. Of course, it's got to be a 90-degree angle. This hypotenuse will be 64 plus 3 root 70 plus 9 root 73. So now, what do I need to find? The sine, 3/root 73. Yep. Piece of cake.
Well, are you gonna, for one that can't simplify, are you gonna make this simplify
Yeah.
Huh?
Yeah.
what's it called? Or onto the radical, are you gonna make this simplify?
Okay, hang on. Don't draw anything for the next ones. Yes, absolutely. I'll talk about that.
What is that divisible by?
Okay, nothing. Let's leave the 73 alone. Poor thing. Just leave it alone. Let's move on. Okay, here we have arc cosine of negative root 2/2. Okay, the ones we did were random numbers. This is now a special angle value, right? What is the angle for which cosine is negative root 2/2? What? It is the 45. Which one is it negative? Did you guys say negative 45?
Yeah.
Okay, so this theta, this is again theta, which is negative 45. So now when I zoom out, I want the cosine of negative 45, which is what? Negative root 2/2. Now, guess what, guys? We didn't have to do all of that work. We didn't have to do any of that work.
Take it.
Because, okay, there is a caveat here. Okay, arc cosine and cosine are inverses of each other. They kind of cancel each other, even though I don't like using that term. So when you see cosine and arc cosine, sine and inverse sine, you can just get rid of this and say it's negative root 2/2 under one condition. This has to be a defined quantity. So for example, if I had arc cosine of -3, that's not in the domain, so it would have been undefined, not possible. You get what I mean?
But if it's within like one,
Okay.
one,
If it's between -1 and 1, then you can find it.
or can you do it also with tan?
Okay, let's do this next one. Yep. This one, no, because it's tangent. So, inverse tangent of -1. So, for what angle is tangent equal to -1? -45 degrees. Facts. What sign of that? -√2/2. You gotta know that unit circle of yours. You have to know that unit circle of yours. So another way to write that is you could say that this is sine of -π/4, -√2/2. Oh my gosh, this is the end of the notes. What a bittersweet moment this is. Wow. Huh?
Never mind, I get it.
Yeah.
I almost called him.
I heard it's Amy.
Oh no. So if this is -1, isn't the tangent of -4? Isn't that the
No,
-2/2
because-
-2/2? So it's just not there.
So you want the angle, yeah, exactly, but only for the 45 degree is that
So what is
possible.